Hello guys, welcome to Sweat Talks. I am Ishrat Noori from Cybersecurity and my team member is Lohita from Cybersecurity. We made this presentation under the guidance of Dr. M. Prasad, Associate Professor, who belongs to the Department of CSE.
Let us understand what is a disk scheduling. Scheduling is a crucial component in operating systems, especially in systems where multiple processes are competing for access to the disk. The goal is to optimize the movement of a disk arm to reduce all seek time and enhance the system performance. In disk scheduling, there are many algorithms, and one of the algorithm today we are discussing is the scan algorithm. So now let us learn about a scan algorithm. The scan algorithm is also called as an elevator algorithm. Is a disk scheduling algorithm that works like an elevator by moving the disk arm back and forth across the disk surface. The arm starts from one end and moves towards the other end, servicing a request along the way. When it reaches the end, it reverses direction and starts servicing request in the opposite direction. Means in a scan algorithm, the disk arm moves in only one direction to to serve all the requests until it reaches the end, and it returns back after completing all the requests in one direction, and it reverses back in the opposite direction to complete its remaining requests. This is called as a scan algorithm, and this is the main reason why the scan algorithm is called as a elevator algorithm. As the elevator position moves in only one direction, either in upper direction first, and it reaches its end, and then comes in a reverse direction. In the same way, the scan algorithm also works in the same method. First, it completes all the requests in a single direction, and then it starts a reverse in the direction. In this scan algorithm, the disk arm will not come back in the middle of the uh, request while going in a single direction. After reaching the end, only then it will come back in the reverse direction. Now let us learn about a scan algorithm operation. There are four main operations in a scan algorithm operations. They are initialization, movement, servicing request, completion. Let us come to the initialization. First, the disk arm starts at one end of the disk. It has a direction of a movement either towards the outermost of the track or towards the innermost of the track. The second step, movement. The disk arm moves in the chosen direction, servicing requests along the way. When it reaches the end of the disk in one direction, it reverses its direction without servicing requests. Third step, the servicing requests. Requests are serviced in a other order they are encountered during the disk movement. Requests on the current path of the arm are satisfied. Fourth step is the completion. The algorithm continues until all the requests are serviced. But the thing should be observed here is the disk arm will be moved in only a single direction, and then it starts in a reverse direction. It doesn't go back in the middle of its way for receive a new request. It completes all the requests in the same direction, and then it starts the new request.
As we discussed about this in previous part, disk scheduling is a crucial part of operating systems, ensuring efficient data retrieval from hard disk drives. This back and forth movement helps reduce disk arm movement and improves overall disk performance. It's a popular algorithm used in operating systems to optimize disk operations.
To understand more about this scan algorithm in disk scheduling, let us consider an example. Consider a disk with a track number from 0 to 199, which consists of a 200 disk in the disk from 0 to 199. The disk arm is initially at the track number 50, E moving towards the outermost track, and there are 4 pending disk requests at a track 82, 170, 43, and 90. In the initial state, the disk arm at the track 50 and the pending requests are 82, 170, 43, and 90. The movement towards the outer track, the disk arm moves towards track 199, serving the requests 82, 90, and 170 on the way. Reversal and a movement towards the inner track. Upon this reaching track 199, the arm reverses its direction. It moves towards the track 0, servicing requests 49 and 90 on the way. Completion of the requests. The arm continues until all the requests are served, which means after completing the request 82, 90, and 170, it reverses back its direction in the opposite direction and it completes the pending request 43 in the opposite direction. For a better understanding, now let us take another example. Let us consider a scenario where disk requests are represented by a queue of part numbers 98, 183, 37, 122, 14, 124, 65, and 67. It starts at the track number 53. Let us assume that the track head is at the track number 53. Now, scan moves the head towards the end, servicing the request in its path, which are 65, 67, 98, 122, 128, and 183, and it moves until it reaches one end of a track, and it starts in a reverse direction. Then the head reverses its direction and moves towards the other end, servicing the remaining requests like 37 and 14 in this example.
Now let's discuss about how scan works. Coming to the step 1, the head of the disk starts at a specific track, and the head movement is somewhat like this. The head moves in one direction, servicing requests along the way until it reaches the end of the disk. The final step is in reverse direction. Upon reaching the end, the head swiftly reverses direction, completing the unprocessed request on its way back. So scan disk scheduling algorithm has some advantages. The first one is reduced seek time by minimizing back and forth movement by the disk arm. And the second one is fairness in servicing requests, preventing starvation of any particular request. And the efficient disk utilization, minimizing wasted time and maximizing performance. And it is relatively simple to implement compared to other complex algorithms. It can be improved throughput and system performance through optimized disk access patterns. Now it's time to discuss about the disadvantages. Scan disk scheduling algorithm also has some disadvantages. The first one is increased latency for requests located towards the outer tracks of the disk as they are serviced later in the scanning process. And it also causes inefficiency in handling sudden bursts of requests as scan may need to scan the entire disk before reaching newly arrived requests. And it leads to the lack of prioritization for urgent or time-sensitive requests as scan treats all requests equally. It has a limited adaptability to changing workload patterns as scan follows a fixed scanning pattern. Here are some real-world examples of scan. We can use scan in scan snap codes. We can send a snap code to add a friend, unlock a lens, or access other Snapchat experiences. We can scan QR codes to open website directly in Snapchat browser. We can scan our surroundings to find relevant lenses like ones related to food or famous landmarks. We can scan outerwear